have the best pizza in the world. Would you like half of it, or would you like a fourth of it? I didn't offer you all of it. Half of it or a fourth of it. You are hungry. You have not eaten in 2 days. Okay. How many of you would say you would like half of it? Okay, here's your half. Here's the whole pizza. I'm giving you 1/2 of it. That seem fair enough? It's what you asked for. However, if you had asked for a fourth of it, you would be getting this much. There's a moral to this story. Fractions are all based on knowing what the whole is. A half of a very small whole isn't very much. A tenth of a huge whole is going to be a lot bigger. That is a very, very important part of fractions. The two most important things of fractions is you have to know what the whole is, and they are equal parts. That is the foundation of fractions. Okay, I got started rambling. I'm Carol Little. I'm the math coordinator. Some of you, I feel like we're like best buddies. We could go out to coffee together. Some of you, welcome. I probably haven't met you. I also get to know you guys as parents, and I have no idea who your kids are. And then I see you together, I'm like, oh, okay. I am in charge of pre-K through 5. I am in charge of ensuring that your kids are ready to go to middle school. I also have quite a connection to middle school because my husband's the 7th grade math teacher. So I have a really good idea of what's happening pre-K through 8 and making sure that it's aligned. You probably haven't done this level of fractions for a long, long time. So let's open our page, and I'm just going to give you the time to look at this vocabulary. Some of it may be new to you, and some of it's like, oh, yes, I remember that. Yeah. This type of stuff, you're going to be better off reading your own page. You're going to have to remind me to move the page up and down because I will forget. Because you remind me. The language in this unit is pretty important. We do use numerator and denominator because that is the correct mathematical term. Numerator tells you how many of the pieces you have, and denominator tells you the size or how many the whole was cut into. We describe them a lot. We talk about them a lot. If there's a puzzled look, we try to explain it again. But your children should know what numerator and denominator means by the end of the unit. We do not specifically test it, but if they're not understanding that language, they're going to have a hard time understanding what's going on. Unit fraction is a fancy mathematical name for 1/2, 1/4, 1/6. It's the smallest unit of the fraction. We deal a lot with unit fractions in 3rd grade. And equivalent fractions, just by the way they're working, they will get used to that term. But that is language we will be using. It is the proper, but as I said, it's not a vocabulary question on the test, but we will ask questions such as, what is the equivalent fraction to? So the vocabulary in this unit might be new right now, but by the end of the unit, your children will be very used to this language. I did give you some of the models. That's what we're going to look at today. If you have been with me for several years, we have been doing tape diagrams since 1st grade. The number line is one of the big changes that I was never taught fractions with a number line. The number line is the one that really helps us understand the size of a fraction and that it is a number. 1/2 is between 0 and 1. And number bonds, how we can break apart fractions. We're coming back to them. We used them a lot in first grade. We kind of moved away from them in second grade because they weren't overly needed for understanding, and we're coming back to them in third and fourth grade. So as I have said over the years, we use models to help us understand something. And we use models that we can understand many things with. So we can use these with whole numbers. Now we're back to relearning, or not relearning, learning something new about fractions. So we're going back to our models that help us understand. Okay. You have 5 colored pieces of this. These are going to become our fraction strips. And I'm going to behave like your child's teacher. I'm going to ask you to use a specific color for a specific fraction. Obviously, any one of these could be folded into halves. The reason teachers care about the color is that if we're using halves and thirds, and I know that they're purples and oranges, and I look around and he's got yellow out, I know where I should be walking and checking in to see who might be not understanding. So it's just a visual clue for us. So we're going to fold first. Let's take purple. Match up the edges because we want equal pieces. We're going to fold it once. How many pieces do we have? I see a lot of nodding heads. I haven't heard anything. You know, we always have one. Okay, so there are 2 pieces. Of course, I start off with one. I don't know. We are going to label each of the pieces 1/2. This is going to be important. This part is worth 1/2. I personally like drawing, I do a dashed line because sometimes a solid line makes it look like 2 separate pieces where I have 2 halves. I don't know what color, I don't know what order your strips are in, it doesn't matter. We're going to take the orange. We're going to fold it in half. We have our 2 halves. But if I leave it folded, and I fold it again, so I'm cutting that half in half. This is that first realization of what happens when you start dividing them in halves. I now have 4. We do. We're going to label each one fourths. What do you think I'm going to do? Started with a half. I'm going to fold it into fourths. How many will I have if I fold it again? 8. Kids won't necessarily know that. All of them won't know it. And for a couple kids, we now have to start talking about what is reasonably accurate. We should be doing our best to fold it in half exactly and fold it in half again and exactly. Are these, if you were to put it into a computer and measure it? No, they're probably not. But they are within reason. And when we start drawing our pictures, we expect their pictures to be within reason. Let's label these. And as I said, I draw these dotted lines just so that I can see them better. Not sure that all teachers would ask the kids to, and if a child doesn't do it, I'm going to let them skip it. So if you lay your 3 fraction strips out, Could you talk to a neighbor? What do you notice? Looking at the 3 fraction strips, what do you see?
Or the same size?
I hope so. Yes, but at 3rd grade, we need to say that. They all started at the same size. What else?
Equal.
What's equal?
All the parts are equal.
Explain that to me some more.
So, in first, in the blue one, both parts are equal.
Perfect.
4 is equal to 8 and
Okay. Is this equal to this? So that's where I'm going to be careful on the language I use, because you knew exactly what you meant and you were right, but I've got to make sure that they hear it so that it's right to all the mathematics. So we would talk about, well, no, 1 isn't equal to 1/2. But what is?
4 is equal to 1
So
half.
4/8, or 4 of these unit fractions. They might not even know to call it 4/8 yet, but they have it right there in front of them. And this is this first exploration into unit fractions and equivalent fractions. And it's right there in front of them. And we start with these. This was easy. And I will tell you, in 3rd grade, we only use halves, fourths, eighths, and thirds and sixths. So this is the next one we're going to get to. Thirds. This is the day teachers get gray hair. The best way we can say is, take your strip and start turning it into a circle. And overlapping edges. Okay? What you're going to do is kind of, very scientific, squish it down, and then you can start, as you squish it down, you can start making these fairly even pieces, fairly equal pieces. I'm not sure if you can see. Yeah, the color's not helping me here. And this is where we have to get into an acceptable margin of error. Before you crease it hard, turn and talk to your table mates. Is yours reasonable?
But yours is reasonable.
And then here's the other thing, we always have extras. If a child can't do this, I am not going to stand over them. I'm going to hand it to them. Did somebody need an extra one back here? So yes, it's important that they understand fractions. Is it important that they can build it from this? That's not the key understanding. Do you have a set of strips? No.
For sure.
Okay, well, I do have plenty. Oh, okay. And I may have, by this time, I also may have scrounged. So, would you please label these? And you probably know what to do with the blue one. We need sixths. Well, it's fine.
Do that and put it in half. You put it into thirds and then put it in half.
I just did a lot of professional learning with teachers, and I asked them what they came out of it after reading this article, and one of them said, math class should be loud. Math class should be full of talking. I'm wandering the classroom and I know you're talking about this, I'm walking away because you guys could be making far better connections than what I'm trying to say. If you're talking about last night's television program, I'm probably going to stop by and ask a different question. And that is why teachers don't sit at their desks and say, go do the math. Okay, so we did thirds, fold it again, and you will get sixths. So do the thirds like you did the green. And once you have that, you just fold it in half, you get six. We do not ask you to make ninths. 3rd grade will work with fifths and tenths. We don't try to build that. We start using those when we understand the pattern of these that we built. toolkit that the kids use for quite some time. And whenever they need to go back to prove something, they should have this available. There is nothing special about the colors. If you've got printer paper at home, you can do this. For a teacher, it's just easier to be able to see the colors from a distance. Fractions are not related to it. So you could make these at home at any time. Sitting at your table, you might see that some people's are thinner strips, because we just did them. But your 5 were all the same size. So again, that whole being the same size is incredibly important. Okay, you're going to be using these later, so hold on to them. In the classroom, we have to make you put your name on the back of them because they're identical. I think you can keep yours though. Okay. These are called fraction strips. They are exactly also like a tape diagram. So we're starting to see our models are starting to overlap and can be used multiple ways. So on these aren't. When we get to the problems, Noah, Pedro, Mac, and Sharon want to share a whole candy bar fairly. Which of your fraction strips shows how they can each get an equal part? Show me your fraction strip that shows what they'll get. Yeah, I'm now seeing that. It might be red, it might be orange. It was the bin of construction paper. Okay. It then says, draw the fraction strip. Are you going to be able to draw this on your piece of paper? It's too big. So, here we are. We have our model. How do we draw a representation of it? By 3rd grade, we should be able to understand. I've never had a child particularly have trouble with that. So I'm going to draw something that looks like it, but I'm not tracing it. So I have my strip, kind of just like I folded it. I'm going to put it into 2 pieces and then 4 pieces. And that's fairly accurate. I have a very strong belief that there should not be rulers out because of the time it will take for kids to start drawing with rulers, and I really think they should be able to draw this within reason in the class. I can't say that all teachers agree with that. If a child's using a ruler quickly and reasonably, that's fine, but I would not encourage it at home. That's getting to a level of precision that actually you'll never meet. So, okay, draw a fraction strip that represents the candy bar. Label to show who gets what. I think Noah gets 1, Pedro gets 1, Mac gets 1, and Sharon gets 1. Label the fraction of the candy bar Sharon gets. Here's Sharon. She gets 1/4. 3rd grade is the first time where we use this notation of how to use fractions. In 2nd grade, we talked about halves and fourths, but we used words. Kids have seen them all around. They probably know it, but this is the first time we're really using it. We will use 1/4 and 1/4 interchangeably because the world does. They should be aware of both of it. Am I going to explain it to any child who doesn't know? I mean, 1/4 is the one they're not going to know. Absolutely, I'm going to explain it. I can explain where it comes from. Okay, Nasir baked a pie and cut it in 4ths. He then took each of the pieces and cut them in half. Draw the fraction strip that represents that pie. 1/8. It is exactly, and this is why us building these fraction strips instead of me handing them out nice and colored and printed, it is exactly what we did. We built this with 1/4, then we cut each one in half, and we got 1/8. Now I'm going to draw it. I am now on to a new problem. I don't have to have it the same size as the problem above. I drew it bigger because I knew I had to draw more lines, and that is an important thing. We have some kids who do this. It's like, you're going to have a really hard time drawing 8s in there, especially when we gave you this much space. Same being, the child who draws it like this is probably also going to get into trouble. So we are talking about space management also here. And we can have paper on the side that they can do it on other paper instead of if this is too small. Okay, so we needed fourths. We get pretty good at drawing them. I cut them in halves. And I'm going to take each of the pieces and cut them in half, draw a fraction. What fraction of the original pie does each piece represent? You told me, 1/8. Macerate 1 piece on Wednesday and 2 pieces on Thursday. 1 here, 2 on Thursday. What fraction of the original pie was not eaten? 1/8, 1/8, 1/8, 1/8, 1/8. I can count those. 1/8, 2/8, 3/8, 4/8, 5/8. Okay, 8 was not. How much was eaten? If you put together what was eaten and what wasn't eaten, you will get 8/8. So I'm not going to tell you, I'm going to say maybe we're into the second week. Yes?
How big is your
I could not eat. Yeah. Yeah, and I wrote it up here. This is just a word problem. I'm not asking them to explain their thinking. This is just getting Russian. Yeah, it doesn't say explain your thinking. We kind of just accept that. We know that the thinking is up here on the sheet. Okay, it's into week 2, and a lot of kids really, after 1 or 2 days of this, they get it. They're there for them to have, but a lot of them are ready to move to just the pictorial representation or the visual representation, and that's fine. These will stay available, but we do move on. We do not expect them to walk around the rest of their life with fraction strips in their back pocket. So, we do practice. Can I do it with just looking at this? So, a fraction strip is one whole. Write fractions to label the shaded and unshaded part. If you have students who English is not their first language, shaded and unshaded could be a tough thing to begin with. It's used a lot, they will get there, but shaded, if you can talk about a shade an umbrella gives, it's the darkened portion. But that is one of the vocabulary things that we will have to explain. So this is unshaded. How many? Well, how many do I have in my whole? 4. How many are not shaded? 3. I still have 4 in my whole, and I have 1 that is shaded. I think there's a pamphlet over on the table. Could you go ahead and do the next one? If we're going to have misconceptions or problems right now, it's going to show up looking like this, where a child immediately reverted back to just counting the squares. This is not right. This is our whole, and I start making kids label that this is our whole. And in 4th grade, that becomes particularly important. So if this is our whole, I now know 5, 6, 7, and I have 1, 2, 3, 4, 5, 6 out of the 7. Now, a few minutes ago, I told you we work in halves, fourths, eighths, sixths, and thirds. On these pictures, we're not overly worried about the denominator because the picture's already drawn and they don't have to make it. We do want them to understand that a whole can be cut into any number of parts. Okay, Okay, Maya finished 1/3 of her homework on Saturday. What fraction of her homework has she not finished? Draw and explain. Okay, so we're going to draw. We have thirds. I need to show Saturday. She finished 1/3. She has not finished. So here I do need to, I drew it. I've got my picture. Who is this? Maya. Has not finished 2/3 of her homework. I would kind of expect that to be labeled or written as 2/3 someplace. Remember, you're getting the crash course. You're getting this in 50 minutes. This is a decently long, I think it's 4, 5, 6 weeks. It's probably at least till spring break. They are going to do this over and over again. They have to see for themselves that when we deal with 1/3s, they have the same properties as dealing with 1/4. The fractions work the same way no matter what the denominator is. And they need proof of this by doing it. Okay, now we're going to put the fraction strips away and move to a different model. We're going to be looking at this is the absolutely just blocked number bonds. What I wanted to show you at the top is the number bond they were using in first grade. We can take 28 and we can break it apart by place value and make it 20 and 8. Or maybe I was doing some sort of addition where it made sense for me to break it apart as 25 and 3. Or I might have chosen to do 2, 20, and have another part which would be 6. We've discovered that if we only have 2 in here all the time, they think there can only be 2. That's not true. We use the language part, whole a lot. It's part, whole, it's part, whole, it's part, whole. You may break a number apart into anything that helps you with what you're doing mathematically. So when we get to fractions, this one is asking us to make unit fractions. So if I have a whole and I have 2 parts, what are my 2 fractions going to be? Yep, they're going to be 1/2 and 1/2. That is specifically because we were asked to build unit fractions. If I have 3 parts, right. And we don't count up into these little bonds. It's not 1/3, 2/3, 3/3. These are what we can break them into. The next model says non-unit fractions. Okay, I'm not going to have one of them. How can I break one apart into non-units? Well, I can do 2/4 and 2/4. And I'm not sure on this lesson, maybe I would do 1/4 and 3/4. But I'm getting to the part where I understand that I can break this apart into anything I need. I may pull this back out and say, okay, I'm going to break my model right here. My 2 bonds, which one do I have? 1, 2, 3, 4, 5. I've got 8s. Would be 3/8 and 5/8. Could I build another one? Sure, I could build it right here. I have 4/8 and 4/8. Can I do it right here? Yes, I have 7/8 and 1/8. And at some point, it's going to make a difference to me whether I have 1/8 and 7/8 or 7/8 and 1/8. We know that computationally they end up the same value, but when I'm going to help myself and I'm decomposing a number to help me do something, I may choose how I'm picking that up, and it may make a difference to me. And it may make a difference to the story the problem has. Draw a number bond showing the fraction of the meat on the grill and the fraction in the refrigerator. I start with 1 whole. They told me I had 1/4. How much went into the refrigerator? 3/4. If I put those two together, do they add up to that 1? I can prove it. I have 1/4 and I have 3/4. At this point, I have some kids using this, and I have some kids who can visualize it and think about it in their heads. Jasmine ate 3/5 of the pizza. What part of the pizza is left? Draw a number bond. This particular lesson, we are practicing number bonds. If you see it a different way, such as a tape diagram or a number line, that's great. Today, all of us are practicing number bonds.
I have a question.
Mhm.
Why you don't do the 5-5 instead of 1? It's more you should visualize better for the kid. I don't know.
And I could. I think I would naturally put 1, and if a child asked me that, we would have a real good discussion. Is 5/5 the same thing?
Yeah.
That's one of those fluency things that we do start with a whole, and I think most kids usually see it as a whole. I would be more than glad to put both of those there. I would probably do it 1 inside and 1 outside, just not to look like 1 5/5. But I think that's a great discussion to have. At this point, we haven't talked a lot that 8/8 equals 1. I mean, it's intuitively it's there, but we really haven't had that as a lesson. And I would love that if that came up in class. What a great way to naturally move into that. So what was this? Was 3/5, and there would be 2/5. I lost my 2/5 left over. We do want to show you that we can break down number bonds all the way to unit fractions. I could break that unit fraction apart again. I could break this one again. And this is more just an exercise for understanding. I don't know when it would be practical. I could see breaking it apart down for addition later, probably more in 4th grade. But just that understanding that we eventually, especially if we know this is 5/5, we can see that we get down to 5 of our unit fractions. I want to move on to, excuse me, the number line, because there are some things that are a little interesting about shifting from the fraction strip to a number line. In our fraction strip, we label each unit part. On a number line, it is a different sort of, it is a measurement model. So we are accruing things. We are adding along as we go, and we count when we get to this part. So, what is this? This is halves. I have 1/2 here, and I have 1/2 here. On a number line, on a measurement model, I have 1/2 at that same fold place, and that's where I label it, because I have traveled that entire distance to get to 1/2. This is what we call an area model. We are looking at this whole area, so I label it in the middle. On a number line, we are traveling a distance, we get to 1/2. And this is where the lesson really comes into, when I travel it again, I now have 2/2. And it's at this point where we really talk about 2/2 equals 1. And this takes practice. I know in my class, I would have these out on the table and I would give them a whiteboard marker. And they would be so happy because I'm going to tell them they're going to write on the table. And they think that's fabulous. And we would draw the number line underneath it. And we would talk about why we are labeling it. And I can't be the one doing all the talking. I have to have them talking about, oh, we label it here because I've traveled this distance. And I need to get them saying it and understanding where that So the next one is 1. Oh, it says fourths. I'm going to, I did that, I really do usually use dotted lines because to me a solid line cuts it in half. I'm not going to be that picky with kids, but it is something I usually model. So I have 1/4. This area is 1/4. This area is 1/4. This area is 1/4. It's still fourths on my number line. If I travel this distance, that's where I have to put my 1/4. Travel this distance, I have traveled both of these, and this is 2/4. Traveling again, I have 3/4, and here we're going to come back, and once again, see that I have 4/4, and that can also be written as 1. A ribbon is 1 meter long. Mrs. Lewis wants to sew a bead every 1/5 meter. The first bead is at 1/5 meter. The last bead is at 1 meter. Draw a number line from 0 to 1. So say, and show where Mrs. Lewis will sew on the beads. So it's fifths. This is what we talk about with fifths. I find where 1/2 is, and then I move a little over, I drop that in half. We talk a lot about how to draw it, but again, we're within reason. Ah, thank you. This is my first fifth, and she sewed a bead here. This is my second fifth. She sewed a bead every fifth. So there's going to be beads at each one of these. How many beads in all did she need? She needs 5 beads. This is where we need students thinking. A lot of kids are going to either put 1/5 or 5/5, but they're not answering the real question. You have to get kids comfortable that just because we're talking about fractions doesn't mean the answer is a fraction. And when kids aren't thinking, I've listened to kids say, well, I know it's 5, but we're doing fractions, so I'm writing down 5/5. You have to get them thinking about the answer and does that make sense? And they have to be comfortable that we're doing math. We're not actually just doing fractions. So this answer is, who is this? Mrs. Lewis needs 5 beads. And when a child looks at you and says, I know it's 5, but I'm writing down 5/5, you just kind of go, okay, let's try that again. Let's count these. And we just have to be gentle and know that we're going to get there. And it might be tomorrow, and it might be the next day, and it might be the beginning of 4th grade. All kids will get there. Now, we work a lot from 0 to 1 in the first part of the unit, and then we need to see, but fractions go beyond 1. They're simply numbers. And so we work a lot between, I would say, 1 and 3, or 0 and 3. So on this number line, we have 0 halves, 1/2, 2 halves is the same as 1. Then we have 3 halves, and then we have 4 halves. A child is welcome to write this as 1.5, but most mathematicians wouldn't. We don't fill in every single little number for each fraction area. Yeah. So, if we look at this number line, it's asking us to do thirds. Here's a very important thing, is we're wanting them to understand where they start on the number line. The reason number lines have these arrows on it is number lines go on ad infinitum, either direction. What we have to know is we don't always start at 0. This is not trying to be a catch-up because you didn't pay attention, but we are trying to get these kids to look at details. And I don't know why, because I think a a lot of the games kids play are very detail oriented, but we seem to be having more and more problems with kids just skipping over details. I don't know if it's watching it really carefully or just thinking, I think it's a going quickly thing.
But sometimes start with 0.
And the very first time we do it, it's starting at 0. I'm moving a lot faster. The kids would have started with 0 here. They would have done a bunch of them. But we will get to a point of that they should understand, if this is 1 and I'm working in thirds, what is this going to be? This is going to be 3/3. But yes, we're moving very quickly. They would have started with 0 with a lot of practice with that. So if we have 3/3, this needs to be cut into thirds. I have 4/3, 5/3, and 6/3. Please, I beg of you, I may come after you, do not show them a multiplication trick to figure out how many thirds there are in 2. They're not ready for it, they don't understand it. They need to figure out that it's 6/3 because they've built it and they've drawn it. You will find equivalent fractions in 4th grade using multiplication. And the multiplication of fractions is really a 5th grade skill. Components and multiplying by whole numbers that we'll do in 4th grade. Right now, they need to understand that because they can see it, because they can build it. Okay, for a measurement project in math class, students measured the lengths of their little fingers. Alex is measured 2 inches long. Jeremiah's little finger was 7/4 inches long. Whose finger is longer? And this problem kind of is why we don't have to start at 0. If a child wants to start their number line at 0, they are welcome to. And I'm guessing, well, let's start at 0 on 1 and we'll start higher on the next one. I need fourths, so I'm going to get to 1, and I know I need to get to 2. So if this is Alex's finger, I know that this is 8/4. And now that I've made that understanding, whose finger is longer, I now know Alex's is longer. Am I going to expect them to show this on the number line? Absolutely. Here's Jeremiah's finger. It is 7/4. Just asking which one's bigger. But we made that 2 inches get changed to 4ths. There will be students who might figure out that they only have to label between 1 and 2 because they know that 1 is 4/4. Their smallest fraction is 7/4. That's the type thinking we really want to see. Another child may take 7/4 and turn it into 4/4. How am I going to help myself? 3/4, but they know that that's 1. So they know that it's 1 3/4 compared to 2, and they know that it is less than.
You can't see.
Ah, thank you. Yeah, when I blow it up.
Yeah, okay.
There are a lot of ways of solving this answer. But what you have to do, children have to do, is somehow show me their thinking. Just telling me that 2 is greater than 7/4, I don't know how they know that. And that could just be a guess. You could draw it. Have 2 sets of fourths with our tape diagram. This is where, sorry, I'm going to label it down here. This is where that labeling of 1 is so important. Like counting, we have 2. This would be, who would we have? Jerome, I get their names mixed up. Alex has the longer finger. So this is Alex's finger. this is Jeremiah's. All three models work for showing this answer. No, which part of it? And this is towards the end. We are at the end of the week. So the big part was we had to use this information, the fact that it was fourths, to know how to cut up our holes. And I could have started with, okay, I'm going to cut up 1. I have 1, I cut it into fourths. Here's my 0. And I got here and I have 1/4 and I have 2/4 and I have 3/4, but that doesn't help me with my problem. So I need to go another 1. So that's kind of the incremental steps that you would go. So I skipped to understanding that. Yeah.
The take diagonal should be 1 and 1. So the 1 is 1.
Okay, I've got a problem that I've got numbers left over from other problems. These numbers don't belong with it.
Okay, yes, and answer.
So I have 1.
1 and 1.
Okay.
The whole of it.
And that starts becoming tough. Yeah, I probably wouldn't even label the second one, because if I label the first one, I tell you what the whole is. And that's probably, I even hesitated. I went, what do I do there? You probably only label, because what I'm giving you is the information of what one whole is. Thank you. Or what a whole is. Yeah.
Should we assume that they know 2 inches 8/4 or no? It's just by drawing it.
By this time they've had by this time they know that 8/4, if they've drawn it, they'll know that it equals
So
2.
it's drawing
Yep.
that would
Yep.
lead that. But the main thing in this problem is the denominator that's going to help us how to find.
The main thing is the denominator and understanding above 1, you have that 5/4, 6/4, 7/4, 8/4. And they will have practiced that quite a bit. When you say, do they know it? They'll know it on paper. If a child was walking out the door and I said, how much is 8/4 worth? I think some of them will know it pretty easily and some of them won't. They will not know it because you divide 8 divided by 4.
For them drawing the 1 and the 2 and then cutting it into 4 is what's going to lead them to 1.
And that's what we have to know, is that the mathematics is there, we have to use the information. So that 3/4 was the important, read it up there. Or here, 7/4, where it says the fourths, that's what gave us the clue as to what our fractions were going to be. Any other questions? How many of you started coming to these years ago when I would go 10, 15 minutes late? We are done. That is the extent of the fractions your child's going to learn. I'm going to tell you about these multiplication sites. Your kids have finished their main multiplication units. By the end of 3rd grade, they're supposed to know from memory and using strategies their times tables up through 9 times 9. I've given you a whole bunch of games that are fun to play. It's still early, it's only February. Probably when we get back from spring break, the teachers might start assigning this, but these are fun games and they can practice, maybe they're 3s, maybe they're 6s. But it is time that they start thinking about it. Drilling with flashcards isn't very successful. It's successful for some. These games are just a lot more fun, and a lot of these have visual components that help them solve it. If they're not fun, don't do them. These are just meant to be add-ons. I would also say maybe 5 minutes a day. This is not something that you sit down and do an hour and a half on Friday. Our brain doesn't learn best by cramming. It does best over spaced practice over time. I'm giving these out a little early. If you would go to Tanin next week when this is published, they'll also be live as opposed to having to type these in. Extension sites, if your child is doing fine, these are the same tried and true that I say every time, practically to every grade level. Math Playground, although I think they're starting to charge. Some of their games are available and some of them they want you to pay. I don't think it costs much, I don't know. It's an excellent site. But in particular, if this is easy for your kids and you want to extend them, don't keep doing fractions. Go to logic games. Because that's what's going to extend their knowledge. Instead of just learning more computation, these are what's going to really challenge them. Math Cats is, if you have a child who likes math, or cats, everything is about cats, and I personally find it a little odd. Cut the Knot, again, is just another one. Common Sense Media you should be using for everything. The games they want to play, the books they want to watch, the TV or video they're watching. It gives you, it's a nonprofit, unbiased review of things. They will tell you whether they cost money, they'll tell you whether there are ads on them, and they are, I mean, these places are now targeting ads so cleverly that I don't know that you want your third graders exposed to that. They'll also talk about maturity levels. Math Before Bed and Bedtime Math, two new ones on the scene. Why they had to have such similar names. If we read a book every night, shouldn't we be talking about math every night? The answer is yes. These are really clever, fun. It's not like doing homework. There's a lot of pictures like what's alike, what's different. I just asked you to check it out, and maybe not every night, but maybe once a week you can go to it. They are two completely different websites. They look different, they work differently, but they're still offering the same type philosophy. If we are having positive, fun chats at home about math, we are going to have that disposition that math is fun and engaging. So those are the two new ones that I highly recommend. Thank you very much for coming.